Let's look at one other problem that is a little bit different. In this case, we have an aqueous solution that contains these two species. If you look at them closely, hopefully you can recognize that we have an acid here that is found with chloride associated with it and its conjugate base, or we have a base and its conjugate acid. The concentration of this is 0.5 molar and the pH of the solution is 4.20. What is the concentration then of this weak acid? So before we were given these two concentrations and a Ka value and we could solve for pH. Now we are only given one concentration and a pH. We can look up Ka or Kb and we should be able to solve for this concentration here. Because we have an acid and we have a base, it makes sense just to use Ka. However, you can use Kb. The book actually does a problem like this using Kb. I think it's just going to be easier if anytime you have a weak acid with its conjugate base, you carry out the calculation using Ka. However, if you go to the table, you'll find that there is not a Ka value for this protonated species here without the Cl-. So this right here, of course, is C6H5NH3+. That right there, without the Cl-, is the conjugate acid to this. But we can find a Kb for this base. Well, knowing the Kb, all we need to do is convert it to Ka by dividing it into 1.0 times 10 to the negative 14. Now, knowing the Ka value and the pH, we should be able to solve for the other concentration. However, we will first have to convert the pH to a hydronium concentration so that when we write our Ka expression, we will have everything but the concentration that is requested, the concentration of this conjugate acid to this base. So this concentration was given. We found this by looking up Kb and then converting it to Ka, and we got the hydronium concentration from pH. Now all we need to do is plug in our values, rearrange, and solve for the conjugate acid concentration. You will notice in this calculation that I actually added on the small amount of conjugate base that would be formed when this reaction here would actually occur. We are focusing on Ka. This is the equilibrium reaction for Ka. As this reaction occurs, we are actually going to make a little bit more of this than what is found in solution. However, according to our assumptions, this is not needed because this essentially is X and we have eliminated it in our calculations. So I would encourage you not even to worry about this in these types of calculations also. We can then rearrange the equation and solve for the concentration of the conjugate acid, and you'll find that if we neglected this, we would still get the same value of 1.4 molar.